Morning. Today we're going to talk about the stages of mountain building, the stages of orogeny. And so I've got a drawing for you. Let's get started. Okay, what we have here is land crust, the edge of the continent. We have ocean crust here being subducted beneath the land crust. All this material, the ocean, there's more ocean crust to the right here, and it's pushing this way, putting a force, continent word force, and it's created this volcanic island arc, this volcanic island chain, like the islands of Japan, the Aleutian Islands. This island chain goes, it's long laterally, north and south in our case, and all these plutons are coming up from this melted ocean crust and helping to create this volcanic chain. So the first thing that happens is before this volcanic island chain gets here to the continent, it may be out to the right into the ocean a little bit, it is being developed and it's producing ash, tons and tons and cubic meters of volcanic ash. And if the wind is blowing toward the continent, which in our case with the tectonic mountain building event it was, you get huge piles of ash all on the continent, And an example of this layer of ash in Georgia is the Millbrig bentonite. Bentonite is a special kind of clay that forms from volcanic ash deposits, and it's a very it's a clay that expands mightily when it's wet, and shrinks mightily when it's dry. And there are some areas in the south where you may have heard that if it's wet and you drive a vehicle into that area, it gets stuck big time in this ash-based mud, this bentonite clay. They also use it like if you want to, they use it to line wells with, to keep water from seeping in from the upper 10 feet, from the ground down to 10 feet, because we want the water to seep into the well from deeper down, and it'll be more pure. So they line the outside of the casing with this bentonite clay. So anyway, you get these ash deposits, and we have ash deposits all over the country. So that's number one, ash. If the wind blows toward the mainland, which in our case it has tectonic orogeny, it has. So the next thing that happens is as the island arc or a microcontinent, which is a small continent, or, let's go back. Let's say in the case of an island arc, that's what we had all up and down the eastern United States during the tectonic orogeny. It approaches, and it could be something bigger than just an island arc. It could be a microcontinent. And during the Acadian mountain building event, which happened during Devonian time, the hunk of real estate that crashed into eastern North America was a big microcontinent, and therefore did a lot of crashing. Or it could even be a continent, which is in the case of the Allegheny or Alleghenian orogeny, which happened during the Pennsylvanian and Permian time, where the continent of Africa, or Proto-Africa, some people call it, Gondwana, smashed into Proto-North America. But in any of these three cases, this hunk of crashing land, approaching land, pushes down on the land crust. And that causes a basin to develop here. That funny line is the water line. Water line. It pushes down on the edge of the continent. That does two things. First of all, it creates a basin right next to it. Ocean floods into this low spot, creating a basin. And outside of the basin, the land crust flexes up and comes up above the water. Okay, so this basin is called a forebasin or a foreland basin. And it's very, very wide and very, very shallow in its landward portion, and it can be quite deep in the part that's next to the crashing piece of real estate. This bulge here is likely enough called a forebulge, and in many cases, especially in the taconic, the strata here were limestone, and so when this forebulge was pushed up, the limestone got karsted, as we talked about in a former video, which just means caves form in it. Okay, so you have a forebasin and a forebulge. And as this piece of real estate moves onto the continent, the forebulge migrates across the land and the forebasin migrates across the land. Just to give you an idea of the size of these forebasins, the Appalachian Forebasin, which was the basin formed from the Taconic and then the Acadian and then the Alleghenian mountain building event, was shallow on the landward side, deep on the real estate crashing side, and it went all the way to the Mississippi River, and it was all up and down the eastern United States. So anyway, next thing that happens is in this deeper part, while this piece of crashing real estate is still approaching, you're not getting much material eroded off of it. So, but the material that does come off of it is very, very, very fine black mud, and that mud settles down in this deep portion of the foreland basin, and it's an oxygen poor environment because it's so deep down, and the mud, which may have started out gray, turns black, and it also usually has a bit of radioactivity associated. So you get a layer of black mud in the deep part of the foreland basin, which is near the crashing real estate and further out from the continent. And then beside that, in the shallow part of the basin, you get limestone formed because the water's shallow, the water's warm, and light can penetrate, so you get limestone. So those are the first layers, and when you see that black shale, the black mud turns eventually into shale. An example we have in Georgia is the Chattanooga shale, and that was the shale, the black shale that was deposited that told us that the Alleghenian mountain building event was going to occur. We didn't have black shale down here in Georgia associated with tectonic because we got no crashing during tectonic. That black shale layer is the first diagnostic layer that tells you that mountain building event is coming. Mountain building event has occurred. Obviously, we weren't there when all this occurred, but if we look in the geologic strata and see the black mud, we can tell that was the very beginning of mountain building. Of course, if the wind's blowing right, you're going to have all this ash. And this Millbrig bentonite is all mixed in with our Chickamauga limestone, which was deposited during the taconic for us in this shallow part of the basin. Okay, so volcanic ash deposits all across the land that form bentonite clay. Then you get the black shale in the deep and the limestone in the shallow part. Okay, what happens next? The next thing is that this huge mountain chain that has crashed into the continents begins to erode big time. And the first thing that comes down is shale. Again, and the shale is gray mud, regular gray mud. And so you get a layer of mud filling the basin up. Then on top of that, as erosion continues, you get these big rivers have developed into the land that are bringing down tremendous amounts of sand. At first it could be sand mixed with mud, and then eventually it becomes sand. The coastal plain marches out, filling the basin up with the gray mud first, and then the sand. Just like our coastal plains of today, the Georgia coastal plain is mainly sand, and that's what you get. And the way you tell that the greater part of this erosion is over with and done is if you see a layer of pure white clean sand all across the land. And what is that layer of white clean sand? It's the beaches. It's the beaches. First, the sand comes down, and filling up this basin, and you've got the beach in here, maybe somewhere, and then the beach migrates out, which is the reverse of sea transgression, as we have discussed earlier. It's a land transgression or a prograding erosion situation. So you'll have limestone, mud, and then sand, which is the classic layers that you find when a massive erosion is taking place. Sequatchie sandstone is an example of that down here. I think is in Tennessee. Tuscarora sandstone up in Virginia is a great example, and that's a very widespread layer of sandstone that's been cleaned and cleansed by the ocean waves that have pounded on the beach. And of course the beach migrates to the west this way, and that's why the layer is very widespread. Okay, and then after that, after all the erosion has taken place and this piece of real estate, whether it be an island arc or a microcontinent or a continent, is leveled, then that means this load that was a point load on the edge of the continent is now spread out all across in our case, all across the eastern United States, just about. And that means the land can rise because it's easier to support this weight on this vast surface. When that happens, the pressure that was pushing this way relaxes, and the crust stretches. The forebulge goes down and the crust stretches, and you get some minor block faulting in here. You get basins, grabens, and high spots. Horsts, or high spots are horst. And then you get a little additional influx of sediments. And in the case of taconic, and I think in the case of the Acadian orogeny, you got the North American continent was in the very dry southern trade wind belts, and so the material that got washed into these shallow basins was red mud and sand, and we talked about that earlier. The Red Mountain Formation that came in Silurian, which is a little bit after the taconic mountain building event, filled up these basins and covered a good portion of the land. And you also get salt deposition, evaporite basins where you can get salt deposited like the salt in the Great Lakes because of this horst and graben rifting that occurs after the mountain building event is over and the crust is relaxed and stretched. So the diagnostic sediments of a orogeny are the volcanic ash layers, if the wind blows right, and for sure the dark black mud that turns into dark black shale. That's super diagnostic that the orogeny is here, with a layer of limestone in the shallower portions of this foreland basin. Then you get mud on top of that, as normal as the huge piece of real estate begins to erode, which would represent mud flats covering over the shallow limestone areas. And then on top of that you get sand, the sand beaches, sand deltas, sand beaches, and sand coastal plains, and forming a layer of sand, and that layer of sand is very white and clean, and that's a diagnostic layer that tells you that the erosion period is over. And then you get, after that, after the crust relaxes and rises up, you get this relaxational block faulting You can get a lot of granite plutons in place during this phase, but you also get these red beds, which is just another layer of usually finer material, mud that comes down and fills these basins, and also precipitate basins. So those are the stages of orogeny. I hope that makes sense. And we'll continue with some more stuff about geology. And I hope you have a great day. Pop out.